This is class lesson for section 3.2, part 1, domain and range. Let's begin with finding the domain of these functions algebraically. Okay? The first thing we want to remember is when we find the domain of a function, we are looking for the x values that work. And when you look at number 1, anything works. You can cube any number you'd like, multiply it by 2, subtract by that same number. There are no restrictions. Also, keep in mind, this is a polynomial. So the domain of all polynomials is all reals. So keep that in mind. Let's get to number 2. The first thing you should notice is that the denominator cannot be equal to 0. And what would cause that denominator to be 0? So x plus 1 cannot be equal to 0. Whatever's in the denominator, just write it and then write not equal to 0. So x cannot equal -1. Solve that just like you would an equation. Subtract 1 from both sides. So what do we do? On a number line, we have -1. We cannot have x equal to -1, but we want everything to the right and everything to the left. So the domain is -infinity, going all the way to a -1, jumping up and over on the other side of -1, going all the way to infinity. So only one restriction, and that is that x cannot be equal to -1. In number 3, let's take a look. It's okay to have a 0 in the numerator, so there's no restrictions or issues with the numerator. But that denominator, x squared minus 16, cannot be equal to 0. So let's go ahead and factor that. X plus 4 multiplied by x minus 4, that's a difference of squares, cannot be equal to 0. So x plus 4 cannot be equal to 0. X minus 4 cannot be equal to 0. So x cannot be equal to -4, and x cannot be equal to +4. Let's take a look at that graph. So we have a -4 and a +4. Now this time, let me get a different color pen. We want everything to the left of -4, everything in between, and everything to the right of +4. So actually, we're going to have 1, 2, 3 intervals. Let's write them. So the domain is -infinity, going all the way to -4, union with -4 to 4, union with 4 to infinity. So 3 intervals together. Okay? Notice in number 4, we do have a square root. And when you see a square root, the very first thing you need to do is write whatever is under that root. X plus 4 cannot be less than, and why don't we just write it? Why don't we just write what it has to be? X plus 4 has to be greater than or equal to 0. We can just write what we would like. Okay? So, if that was a 4th root or a 6th root or an 8th root, any even root, you cannot take the root of a negative number. Has to be greater than or equal to 0. Whatever is under that even root. Okay? So, x has to be greater than or equal to -4. Yeah, it's that simple. So you put -4 right here on your graph, and we want everything greater than it. And what did I just do? We also can be equal to -4. It's okay to be equal to -4. So let's go ahead and write our graph here. Our intervals. So our domain will begin at -4 and go all the way to infinity. And we want to include -4. That's why I use that bracket. Okay, at first in number 5, you might think, oh, we have to worry about what's under that root. But this is an odd root. There are no restrictions. You can take the cube root or the 5th root or the 7th root of a negative number. So here our domain is all reals. We're just worried about the square root, the 4th root. Speaking of the 4th root, let's look at number 6. Look at that denominator, okay? So we have two things going on. Not only do we have an even root, but we also have to be careful about the denominator, okay? That denominator can't be equal to 0. So normally you would write x squared plus 6x has to be greater than or equal to 0. But can this be equal to 0? No, it cannot be equal to 0. So we just take that equal sign off, and now we're set. We've taken care of the even root because we don't want it to be equal to 0. And we've taken care of the denominator because we don't have that equals on there anymore. So it makes it really nice. Okay, so let's keep going. We have to factor that x out, and that has to be positive. Now, to have a positive number, when you multiply two things together, you can have a plus times a plus or a minus times a minus. So here we will break this off into two cases, okay? This is important. Either x has to be positive and x plus 6 has to be positive. And let me redo this. Or there's another case. X has to be negative and x plus 6 is negative at the same time. Because when you multiply them together, you will end up with a positive number. So let's solve both of these. So x is greater than 0 and x is greater than negative 6. We're going to look at that and see what's most restrictive. So we have x is less than 0 and x is less than negative 6. So now we've got some restricted cases. Let's take a look. Let's make a graph. And let's start on the left-hand side. X has to be greater than 0 and greater than or equal to negative 6. The most restrictive is x greater than or equal to 0. So here's 0, and we want everything greater. So here we're both greater than 0 and greater than negative 6. So there is the first part. Now let's go look over here. Which is more restrictive? X is less than 0 or x is less than negative 6. So x is less than negative 6 is more restrictive, okay? So we're going to go ahead and put a negative 6 here. And we can have everything less than negative 6. Now, what did I mean by more restrictive? Let me just show you this. Here's negative 6. Here's 0. We say we want everything less than 0 and less than negative 6. Well, you have to go where they satisfy both. Okay? So now, let's write our domain. Our domain here, we're going to have 1, 2 intervals. We're going to go from negative infinity all the way to negative 6 and union that with 0 to infinity. And again, we do not want to include negative 6, nor do we want to include 0 in those. So I'll go ahead and highlight these domains, and we'll move on to the graphical method of looking for domain. And this time, we're going to include range. Okay, take a look here at the x values. If you would write every one of these coordinates down, the ordered pairs, what would you have? You would have everything starting at 2 and going all the way to 6. And you would have no other x values here when you plotted them. That's sort of what we're doing, okay? So I might keep that on the x-axis. So that domain is going to be from 2 to 6. Now look at the range. The range is going to take us from negative 6 all the way to negative 2. And we have closed circles, so we want to include those. So the range starts at -6 and goes all the way to -2. That's it. Okay, let's look at the domain and range in this next one. Look at this domain. It's a little bit difficult to see, but let's just estimate it to be about -2.5. How about that? So we're going to go from -2.5, but we don't want to include it because it's an open circle. And we want to go all the way to positive infinity. And why did I say positive infinity? Because this is going to go on and on and on. And slowly it will tend outward, okay? So all the way to infinity. It's a little bit difficult one, but you do need to try to understand. When you see this arrow, this means, since you see how it's slanting to the right, you can really exaggerate it and say eventually it will do that. Okay, now let's start at the range. We look for the lowest y value and we see it beginning at -4. So we're going to start at -4, and that is a closed interval. And look at that arrow going up. We're going to go all the way to infinity. Okay, let's look at this last one. The domain, we're going to start at -4 and go all the way to infinity. And the range, we're going to start at -2 and go all the way to infinity. You see how this is tending upward? So that's what we will write. And that concludes this first part of 3.2's class lesson.